All right, let's dive right in. We're going deep into the heart of modern cloud infrastructure. And let me tell you, it's a place of incredible power, but also some really surprising fragility. Today, we're going to talk about how to architect for chaos, and more specifically, how to stress test that one component that's holding your entire multi-cloud strategy together.
So just picture this for a second. You've built this amazing, super resilient system. It's spread across AWS, Azure, maybe some Google Cloud. It's beautiful. But what happens when the lines of communication between them start to get a little fuzzy or slow? Or what if they just get cut entirely? What happens when the brain of your whole operation just blinks?
And that brings us to a really core and honestly kind of unsettling truth of our modern world. Your multi-cloud control plane is very often your single biggest point of failure. Think of it like a central nervous system. If it goes down, it can take everything else down with it. It doesn't matter how resilient your individual apps are.
Okay, so to really get a handle on this risk, we've got to walk this tightrope ourselves. So let's break down exactly what this critical component is and why it's so delicate.
Here's probably the best way to think about it. You've got the data plane. That's all the airplanes in the sky actually carrying people. They're your applications doing the real work. But then you have the control plane. That's the air traffic control tower. It's not carrying any passengers, but it is telling every single plane where to go, what to do, and how to avoid a total disaster. Now, in our multi-cloud world, it's like having one single tower trying to manage multiple airports at once. You can see right away how vital and how vulnerable that one tower becomes.
So, if our control plane is this fragile tightrope, how do we get better at walking it without falling? Well, the answer isn't to just keep adding more safety nets below. No, the answer is to practice, deliberately, safely. And that, my friends, is where chaos engineering comes into the picture.
Now, it's really important to get this right. Chaos engineering is not about randomly breaking things just to see what happens. No way. It is a precise, controlled discipline. The goal here isn't destruction. It's all about discovery. And the most important part of this whole thing? Building confidence. Proving to yourself that your system can actually handle the turbulence you know is eventually coming its way. You could almost think of it like a vaccine for your infrastructure. You're proactively injecting a small, controlled weakness to build up immunity. So that when a real-world threat shows up, your system isn't seeing it for the first time. It already knows how to fight it. It's all about finding those hidden weak spots before they find you during a 3 a.m. production outage.
Okay, so we know what chaos engineering is. The next logical question has to be, where do we point this thing? Where are the most vulnerable spots in our multi-cloud control plane? Where do we start? Well, the source material points to three huge ones. First up, API rate limiting. What happens when one of your cloud providers suddenly starts throttling your requests? Can your system handle that gracefully? Then you've got authentication outages. What if the service that validates all the communication between your clouds just vanishes for a few minutes? And of course, the big one, regional failures. What happens when an entire region's control plane, like the infamous US East 1, just goes dark? Any one of these could trigger an absolute catastrophic cascade. And believe me, this isn't just theory. This quote from a real-world postmortem says everything you need to know. A single authentication failure in just one cloud had a domino effect that brought down their entire platform. For 45 minutes, they were totally blind. This right here is the exact nightmare scenario we are trying to prevent.
All right, let's get to the heart of it, the how-to. How do we actually do this? Let's walk through the anatomy of a really well-designed chaos experiment.
See, this is where that whole scientific method thing really comes into play. You don't just go in and break stuff. No, you start by forming a clear hypothesis. Something like, we believe our system will stay stable even if we lose authentication with cloud provider B. Then, and this is crucial, you define the blast radius very, very carefully. This experiment will only affect these three non-critical services. Only then, once you've done that, do you introduce the failure, all while measuring the impact. It's methodical, it's controlled, and most importantly, it's safe.
And this template right here, this is a fantastic starting point. It's your playbook. For any experiment you run, you should clearly define these four things. What's your hypothesis? What's the method you're using to inject the failure? What is the absolute strict blast radius? And maybe the most important one, what's the success metric? How do you know if you passed? What does good even look like? Defining this before you start is the key to actually learning something, instead of just causing problems.
So, all of this, all these experiments and templates, they're all building towards something much bigger. Because running these experiments isn't just another technical task on a checklist. It's a fundamental shift in how we think about building and operating our systems in the first place. So what's the big takeaway here? It means we have to shift our entire mindset away from trying to prevent every single failure, which, let's be honest, is impossible, and towards surviving failures gracefully. It means you have to start small and then expand your blast radius carefully as you build up that confidence. And it means making this a regular practice. It should be like a fire drill for your services. Because ultimately, confidence isn't something you can just assume you have. It's something you have to earn, and you prove it through practice.
And that really brings us to our final thought. The perfect system isn't one that never ever fails. No, the perfect system is one that can withstand any failure. It's anti-fragile. So the goal isn't some impossible standard of 0 failures. The real goal is a journey toward infinite resilience. And the question I want to leave you with is, how close are you?